Hello and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronics supply chain fields. I'm Mike Buetow, Editor-in-Chief of PCD&F and Circuits Assembly. Today's podcast is sponsored by PCB Today, bringing two-day workshops on design and assembly to you. Two new workshops, the SMT Assembly Bootcamp and Design Essentials for the PCB Engineer, are coming soon to Austin, Texas. Check out PCBtoday.com for the latest in electronics training. This week we continue our series called the Screwups. In these segments, we talk with experts in electronics manufacturing about specific problems they've encountered and offer up some potential solutions. I'd like to welcome a new guest this week. Chris Nash is Product Manager for Indium's PCB Assembly Solder Paste. In his role there, he works with the R&D team and provides technical advice in the selection, use, and application of solder paste and flux to electronics assembly customers throughout the world. In addition to his 15 years at Indium, Chris is a certified Six Sigma Green Belt from Dartmouth College's Thayer School of Engineering and is a certified SMT Process Engineer. So Chris, today's topic is solder paste insufficients caused by the printing process. Let's start by going over just what, exactly, is an insufficient solder condition and what the main causes are.
Sure, Mike. Really, an insufficient solder is really due to the printing process itself and or the solder paste material that you're using. It's kind of a combination of the two. And an insufficient would be where solder paste would not deposit in the proper volume onto the board through the stencil. I mean, there could be a number of reasons why that is happening. A lot of it could be due to the rheology of the paste itself. Some of it could just be a clogged aperture or the area ratio of the stencil. Board support's also important as well, but looking at kind of an Ishikawa diagram or a cause and effect diagram of the printing process and transfer efficiency, we'll actually see there's thousands of variables that go into the printing process itself. And going through each and every variable is a daunting task, but an important task to look at if you are having insufficiency.
So if there's that many different variables, where is a process engineer supposed to start?
Really the easiest point to start is, and what most people do, is they'll start looking at the paste itself. You know, does the paste look like the proper viscosity that they're used to? Is the paste clogging the aperture? And so they might take the actual stencil, hold it up to the light, and see if that aperture that produced the insufficient is clogged. But there's also things like board support. I think the number one reason for insufficient solders is really board support or improper board support. And it wouldn't allow for the proper release of the solder paste onto the board from the stencil aperture. So I think really start there and look at clogged apertures and board support as being your number one reasons for an insufficient solder. You could also have area ratio being a major player as well, where if you have improper area ratios, it's going to be more difficult for that solder paste to deposit through the stencil itself.
So if it's clogged apertures that you're seeing, how do you know whether it's a paste issue or simply a stencil design issue? And I shouldn't say simply, because stencil design itself is never a simple thing.
Right. I think from a clogged standpoint, you really have to take into account the area ratio first. So doing a quick calculation and checking to make sure that your aperture meets the 0.66 area ratio or greater is really the first place that I would start. If your area ratio has got a 0.5 calculation, then you might want to consider changing the aperture design itself or even the stencil thickness to get a little bit better area ratio. Although some materials on the market would allow for printing down to a 0.5 or in some cases even lower. And that's really where we go into, say, finer powder sizes like type 5 and type 6 for those smaller, fine feature, tighter area ratio applications.
Do you see more insufficients as the powder type gets smaller? Are we more likely to see this problem as we move to type 5, type 6 pastes?
Well, I think the only reason that you would be is because the area ratios are getting smaller and the apertures are getting smaller. So it's more difficult to transfer through those area ratios than a larger area ratio. So I don't think it's necessarily the paste or the mesh size of the powder that's determining the clogging as much as it is the stencil design, the stencil material and technology that's used. There's a lot of other stencil technology that could be employed in those situations as well.
So is this an application where I might be looking at a nano coating on my stencil as a means to prevent insufficients?
Absolutely. I think there are a lot of nano coating options out there today for stencil technologies. I think not everyone is created equal. So there's definitely nano coatings that are better than others. But the actual stencil aperture, how the aperture was cut, and also the tension of the stencil itself can all play an effect on the transfer efficiency of the paste so that we're getting proper volume on the board.
If I'm having insufficient problems, should I look at my pad design as a possible area that I need to reconsider?
I think pad design is one area that plays a role for certain, but I think where we see insufficiency happening more often is actually the alignment of the aperture to the pad. And I think a lot of panelized boards will have board stretch issues, which could actually play a role in the insufficiency. If the aperture is not aligning with the pad correctly, it's not going to pull the paste out of the aperture or adhere to the board while the board is separating from the stencil. So I think the aperture itself plays a bigger role, but the board can also play a role as well.
Do I need to take a different approach for leadless components versus leaded ones?
No, I don't think that's going to really be a different approach there. I think you're going to be looking at the area ratios and the fine pitch components that you're going to get insufficiency with over larger components or larger aperture sizes.
Chris, let me ask, are you generally able to identify this condition immediately after printing, or is this something that people will occasionally have to wait till everything goes to reflow and then they find out, oh, wait, I've got an insufficient solder condition? That
really depends on if the person, the engineer or the line operator has an SPI. Usually if you have an SPI equipment, you'll be able to catch the insufficiency right after the printing process. The SPI will tell you, oh, we have a defect here, and we can kind of pull that board aside, clean off the solder paste and reprint it, or we can scrap it altogether. It's not something that we'll have to wait till the end of the line to decide or to determine that we have a defect present due to an insufficient solder. So the SPI equipment's really been a very helpful tool to detect insufficient solder occurrence. Now, those pieces of equipment are relatively expensive. Not every mom and pop shop in the world is going to have one, but the big electronic manufacturers out there, I really haven't seen a line that doesn't in a large manufacturing environment.
As a paste manufacturer, do you tend to make the recommendation for how often the assembler cleans the stencil?
Well, what we try to do is we try to extend the frequency of cleaning. So we don't want to slow down the process any more than we have to. And our pastes are designed around that. We'd like to have, what we'd like to do is do a continuous print test on our materials before they're released to the market to make sure that our materials can do and maintain multiple prints, up to 20 to 40 prints, before a wipe is necessary. Now, because of some of the complexities of certain builds and improper setup of builds and the printing process, that's hard to do a lot of times. Usually we'll start out by saying, okay, well, let's introduce a wipe around 1 every 5 prints. And then we'll try to extend it a little bit. And if we can extend it, or the 5 prints is is too much, then we'll scale that back to a point where we're not seeing insufficiencies happening.
Chris, is there anything else that you would recommend users look at if they're having problems with insufficiencies?
I think the solder mask itself, a lot of the solder mask on the board can play a significant role in insufficiencies, especially for solder mask defined pads. Now, I think a lot of pads these days are non-solder mask defined pads, so it becomes a little bit easier from a gasketing standpoint. And by gasketing, what I mean is the board to stencil gasketing, tightness between the two. That being said, we have also seen silkscreen issues where you have the white lettering on the board, and that's a few microns thick. So if you have some near the edge of a pad, that can affect how the stencil is gasketing to the board. So silkscreen, you want to have a keep-out area for the silkscreen around the apertures and around the pads so that you're getting the best gasketing possible.
Great. And Chris, if listeners have issues and they want to reach out to you, how should they do that?
They can contact me directly. My information's on the website, www.indium.com. I can be contacted via email at cnash@indium.com, or my phone number is 315-853-4900.
Chris, will you be at the IPC Apex Expo show coming up the week of February 3rd?
I will. So I will be at booth number 1037 if anyone wants to stop by and talk in person.
Great. Well, that concludes this episode of the Screwups. I want to thank Chris Nash from Indium for coming on, and thanks to our sponsor, PCB Today, bringing workshops on design and assembly to you. Visit PCBtoday.com for details. For the Screwups, this is Mike Buetow. Have a nice day.